I'm sorry, what? I would if I had the copy for you in my room. It's not, it's not with me though. You know what I mean?
Mr. Cooler?
Yes.
How do you rationalize the denominator of a quotient?
Okay. So
like 45.
Will you would just read me it?
3 minus 2i, that's z1, and then z2 is 1 plus I.
Okay. So to rationalize the denominator, I'm just going to multiply the top and bottom by the conjugate. So that's the same thing, which is the different sign in the middle. So then I'll just FOIL out the numerator. And the denominator. So remember that I squared is equal to -1. So when I combine like terms, I get a 1 minus 5i in the numerator and a 2 in the denominator. So I can just think about that as 1 minus 5 over 2i. Yeah, no problem, brother. So that should be relatively easy, right?
Yeah, I just didn't know how to do it.
Yeah, no biggie. That's what the questions are for. Yes, sir.
And you do 49.
Yep.
You need to read it out.
Yeah. Was there, before we move on, was there a question on this? I thought I heard somebody saying something.
Yeah, how'd you get the 1 minus 5i?
3 minus 2 is 1, and then -3i and minus 2i is -5i.
Oh yeah, I suppose. Okay.
Okay. All right, Keys, read it up.
Okay. So it's finding the product of Z1 and Z2.
Yep.
So Z1 is 7 cosine 25 plus I sine 25. Yeah. And then Z2 is 2 cosine 130 plus I sine 130.
Okay. So are there any specific directions for this?
Leave the answer in trigonometric.
Okay. Well, that's super easy. So to do this, I just multiply the coefficients together, and then I add the angles together. Done.
Let's go.
That's in trig form. That's pretty righteous.
Is there a part where you have to do that?
If you want it in standard form, I'm just going to type into my calculator cosine 155 times 14, whatever that decimal is, plus 14 times sine 55, whatever that decimal is, and tack an I on at the end.
Would you mind finding the quotient with the same rows and numbers?
Yeah, so if this is just division,
That's number 50.
okay. So same idea, but this time we're going to be dividing the coefficients and subtracting the angles. Trigonometric form, boom, done. If you want the standard form, you just, 7 over 2 times cosine -105 in your calculator, plus 7 over 2 sine -105 in your calculator, and tack an I on at the end. Bingo, bango, boongo.
How do you use G-Moir's theorem to find Zn?
Okay, well,
I can tell you.
de Moivre's theorem says that for
Yeah, that's what I said. Oh, okay, yes.
says for this is z to the n then is r to the n times cosine of n theta plus I sine n theta. So if you have a specific one, we can apply that then. Yeah.
Okay. 2 cosine 35 plus I sine 35. Then n is 4. And it wants it in trigonometric form. Or wait. And then it wants in trigonometric form with within 360 and 0, but then convert to standard form after that.
Sure. Okay, so that's going to be 2 to the 4th cosine 4 times 35 plus I times sine 4 times 35. 4 times 35 is 140. 2 to the 4th is 16. That's trigonometric form where my theta is clearly between 0 and 360. I didn't even have to worry about coterminaling it. And if I want the standard form then after, Elizabeth, you should have hollered at me that I didn't have the screen projected. I just really looked over and noticed that. My apologies.
That's okay, I was just following along. I didn't notice.
Okay, sorry about that.
That's alright.
If I do anything dumb again, like chime in and let me know to stop doing something dumb. To get this into standard form then, I'm just going to do 16 times cosine of 140. Guess before I do that, let's make sure my mode is in degree. So that's negative 12.26. I guess I should say approximately. And then I'll do 12 times sine 140. And I get 7.71. That's it. So there's trig form and standard form. All right, Holmes. What do you got for me now? This is 73.
Yep, we're finding the cube roots of the indicated complex numbers.
Okay.
Leaving it in trigonometric form between 0 and 360.
Okay.
So 8 cosine 150 plus I sine 150.
And we can't get exact answers out of this probably. Okay. So again, the formula for the nth root, let's write that down first maybe. It's going to be the nth root of r times of theta plus 360k over n plus I sine theta plus n, where k is equal to 0 to n minus 1. So that's our nth root formula. You said we're doing a cube root here for this particular one?
We are, yeah.
I believe if you look at the last page of the review, it has the equation sheet, and I think this is on there. I mean, I don't know how you don't have it memorized. You have those young brains. So I have the times cosine of 160k over 3 plus I times sine k over 3. So when k equals, I have the 8th root of cosine of 150 divided by 3 plus. All right. So if k equals 1, and we have the 8th, well, I'm just going to start writing that as 2. Everybody's okay with that, right?
Yeah.
So there's that. And then 150 plus 360 is like something. 510 divided by 3. It's 170. So there's my second answer. And the next one, k equals 2. So 2 times cosine 150 plus 7 sine 150 by 3. Dang it. So that's 290. Through them. For whatever reason, letting me erase that messy looking 290 there. Oh, finally it let me erase it. So that's my third one. Cool with that? And so, and it's, that was the one problem. So a cube root has 3 answers to it, right? A 4th root's going to have 4 answers. A 5th root's going to have 5 answers, etc.
So for radians, we just convert it to degrees, right?
Or you would just leave what it was in it and adding it to adding 2 pi multiples instead of 360s. But yeah, either way you want to do it is fine with me. You know, whether you're leaving it in degrees and then converting it, or just leaving it all in radians and adding multiples of 2 pi, like that's fine too. No big deal. Either way is fine. They both work.
Alright, yeah, we're good. The rest is just that, but with different numbers.
Right.
Yes.
Wait, so that means doing it part time?
Oh, wait. What does that mean? Okay.
Yes, sir. You read it to me.
And it's -5 times 5 pi.
Okay. And we want a cube root of this, is what you're saying? First thing I'm going to do is convert this into trigonometric form. So I know that r squared is equal to -5 squared plus is 50. So r is 5 square root 2. Okay with that? Okay. Next thing I'm going to do is find my angle theta. So I plot -5, -5, which is down here. So I'm looking at angle theta. To get that, I'm going to use this angle alpha, because theta is 180 plus alpha, where alpha is the tan inverse of the absolute value of, so in this 5. Just real quick before I keep going here, did they want the trigonometric form in radians or degrees on this problem? Before I get going, I'm going to switch, and it doesn't specify? Okay, so I'm going to do it in degrees then, just because it feels like everybody's more comfortable there. So this is going to be then 225 for theta. And that's my R. So that just makes everything a heck of a lot easier to deal with. The 45, I typed in tan inverse of -5 over absolute value of -5 over -5 into my calculator. I didn't need to because there's a unit circle value. I mean, you could do that still and give you 45. Yes, sir.
B is the second one and A is the first one, right? Where B is like.
A is the real part and B is the imaginary part.
Okay, thank you.
Mm-hmm. So just like the XY coordinate, right?
Yeah.
Because the real axis is the horizontal and the imaginary is the vertical. So just like y over x still.
Okay.
Just like our unit circle definition.
Okay, thank you.
Okay, so there's my value, and I want the cube root then of z, which is 560k I sine dk divided by 3. Yep, where k is 1, 0, 1, and 2. Yep, so I'm just going to use the same formula now that I'm in trig form. And the answers here, it was asking for exact or didn't specify? Okay, you mumbled something, I missed it.
Sorry, rounded to the nearest 100.
Okay, so it wants a standard form answer rounded to the nearest 100th. Perfect. I'm not even going to bother with simplifying much of this stuff since I'm just going to type into my calculator anyways. Is that okay with you? So that's my when k is 0. So cube root. So I do math. Of 5 times the square root 2. I guess there was no sense in me simplifying that since we're just going to convert it anyways. 225 divided by 3. So that's 0.497 plus same thing, except I want a sine on there instead of a cosine. So that's 1.854 I. Well, it said 100th or 1,000. I guess it doesn't really matter. You get the gist of it.
Yeah.
I'm not going to worry about it since I don't have the directions in front of me, but close enough, right? So in case 1, same thing, but I'm going to be adding 360. So instead of 225, I want 585. So I'll just go back and alter that and change it to 585. So there's my A. Oops. And I'll change that to a sine. So negative 0.854 and negative 0.47, okay? K equals 2. I'm going to be adding 720, 360 times 2. Still doing okay with all this, Anthony? Okay. So 585 plus 360 is, what's that? That's 945.
Yeah.
Oops, need to change that to a cosine. There's that. And then change it to a sine. Is that. So there's 1357. Oops, I can't remember positives, negatives. So those are the three results. Keys.
This might be a lot to ask, but do you mind if we did like odds on 73 to 120? Because it's a lot of just doing that, but with different n values. It's like, so 73 to 88 is finding the cube root. 89 to 104 is finding the fifth root. And then 105 to 120 is just finding the nth root. And it's like the same with the variation.
Yeah.
Oh, so like end of the 6, you have to do it 5 times?
Yeah.
Oh, there's like a bunch of those too.
Yeah.
So would it be possible if we just did the odds for those?
Well, I mean, like, all you're doing is typing stuff into your calculator.
Well, yeah, but like, I feel like it's gonna take me a long time.
Well, you get good at it then.
Yeah. I'm gonna get very good at it.
Yeah, get very good at it. No, I'd like you to do them all. This is one, and I know you're like, ugh, but this is a place where we actually expanded this problem set because in the past, like, you guys just didn't have enough practice doing this procedure. So like we did expand this section because that students in the past really struggled with this and just didn't get enough practice with it. So I know it's like the same thing over and over again,
Yeah.
but like you need a little bit of practice to get it.
Would
So
it be possible to extend the review date then, the review packet?
Yeah, we have that like the Tuesday.
Yeah, I don't care when you turn it in. Like, that's not a big deal to me. Sophia?
On this test, are there gonna be like problems with like gradients?
Sure.
Are you gonna put like mostly as degrees?
I mean, you should be able to do it either way. It shouldn't really matter to you.
You just convert it with 180 over pi or pi over
Yeah.
You can do that. You can do it that way, or you can just leave it all in radians and still do it.
I'm
It's,
not that comfortable with gradients, that's wondering.
okay.
Also, can you do number 18? It's negative.
Oh, sure. Go ahead, Anthony.
Like, we should do this, like, show all the work each time, we just add it more.
I would say that, like, if you show this, and then if all it's asking for are these, like, if you show me that,
Sorry, yeah.
that seems like adequate work to me to know what you typed in your calculator to get those things.
Just the K value.
Yeah, because all you're doing is changing that value for K. And like, if you get the right numbers, obviously you did it right. And if you didn't get the right numbers, it would be most likely you screwed up a parenthesis like here, like you didn't put 225 and plus 360 in parentheses before you divide by 3 or something silly like that.
How did you get the R value for that exactly?
It's the cube root of r.
Okay, that's it.
Yeah. Yeah, my dude. So the r we found was the square root of 50, or 5 square root 2. Yeah, what's up, my brother?
Can you do 13?
Yeah, sit right after I do 18.
Okay. Oh wait, those are like the same thing. Yeah.
Soph, hit me.
Okay, 1 sec. Let me pull up the direction.
Oh, we don't know.
It's for 18.
Yeah.
It's -6 plus 6 side. It wants you to convert the following complex numbers into a trigonometric form between 0 and 2 pi.
Okay. So I know r squared is -6 squared plus 6 squared. So r is the square root of 720 or 72, which is just 6. Okay with that? Okay. Then I'm going to go ahead and graph this. So I went -6 over and 6. So there's my angle theta. This angle is my alpha. So theta is going to be, in this case, pi minus alpha. And the alpha is going to be tan inverse of the absolute value of b over a. And when I type that into my calculator, well, I should recognize that this is b over a gives me 1, right? So this is a unit circle value. So the place where tangent is equal to 1 is 45 degrees, which is pi over 2, or I'm sorry, pi over 4. I mean, if you did this in degrees, you'd get 45, and you'd immediately recognize that as a unit circle value to convert to radians. Or if you did it in radians, you might get, you know, what is that? It's like, I don't know. It's a little less than 1. Or a little less than 3/4, like 707 maybe or something, I don't know. Anyways, so this is going to be 3/4 pi, or 3 pi over 4. So those are the two things that I need. So my answer is 6 root 2 plus I sine 3 pi over 4. Josh?
Can you still do 13? Or like if there's only an I?
Oh, that's even easier, man. Yeah, I'd love to.
But like,
Take me I'll do it in a minute. Less than a minute. Shoot, what is it?
it's just 3i.
3i. Okay. I'm not even going to bother with any of this. Draw this. 3i is here, right?
Yeah.
So clearly the radius is 3, right? The distance from the origin has to be 3. And the theta here is just 0, right?
Okay.
Since you're on the positive side of the x-axis. So I have 3 sine 0.
Okay. Thank you.
Done. Ha! So the ones where there's just an I, or just if there's just a real part or just the imaginary part, are actually way easier because there's nothing really to do. You just look at the picture and you can tell exactly what the form's going to be,
Okay.
which is lovely, right?
And then if there's 2, you just have to do like.
Then you have to do what we did before in 18.
Okay. Thank you.
Yep. Which is just like kind of resolving a vector and component form to get its magnitude and direction. It's the exact same process.
It's pretty much just like the Pythagorean theorem.
Yeah, or really converting like a rectangular coordinate to a polar coordinate. Same process still. Sophia.
So if it's just a number, would it still be like 0, like the theta would be 0?
Well, depends what the number is. Oh my goodness. I goofed this up
13?
because 3i should be here. So this should be pi over 2.
Oh, I had that right.
Sorry.
So if it has an I, it's pi over 2.
Well, no. If it's an I, it's on the horizontal, or it's on the vertical axis. So if it's a negative I, it's going to be like 3 pi over 2.
So for 16, where it's like just 8, r equals 8.
Then it would be like the one that I just did.
Okay.
So if it's just 8, r is 8, and theta is 0.
Okay, thank you.
Yeah. That's... That's more like it. Sorry about that. Sophia, does that clear things up?
Yes.
Okay. Sorry, I goofed up that first one when I did it. No, I appreciate you asking. Continue to ask questions because I caught it then. Keaton.
Do you want us to simplify coterminal angles?
Well, if they're asking for the angle between 0 and 360 or 0 then 2 pi, absolutely. If the directions don't indicate to do that, it wouldn't bother me if you left it not coterminal. You know, like if it was like if you left it as 450 or something, but if the directions say to make sure it's between, you know, your angle is between 0 and 2 pi or 0 and 360, then yes, I would care.
I wasn't sure if I did this one wrong, because the answer said the angle was 0, I got negative 360.
Same thing,
Okay.
right? They're coterminal, so the only issue would be following directions there. You have the right answer, but I don't know if it followed the directions for that problem. Are you guys feeling any better about this?
Starting to, yeah.
Okay. Therese. Yeah, of course. Amanda.
I have a question about the review, but it's not really like how to do it. It's just that, well, yes, I was just wondering if I was using my calculator wrong because I was getting all of the questions for these ones wrong, but I had the same angle for everything. So I was just wondering if I was typing it in my calculator wrong or if the review was wrong. I don't know.
Okay.
Just kind of wanted that to
So you did that, and you got this number, right?
Yeah.
So let me type this in and see what I get. 116.56 divided by degrees.
Yeah, sure.
Okay, so I get 15.6 for that. I'm going to change that to sine. I get 8.7. Let me check something real quick. Oh, I see the issue there. So on your work, you don't have the fourth root over that stuff, right? Oh, the fourth root of 20. I wrote because you didn't put it. Okay. So when I write them, I put the 4 in the check mark. But no, it's fine. As long as you know what it is, that confused me. Okay. So. Okay, so that's the 184. And there's that's the 101 or 103 or whatever. That's what I got there.
Okay.
And the key says that that one is supposed to be interesting.
Logic is not adding up.
Yeah, that is strange, huh?
I just wanted to make sure I wasn't like doing anything majorly like wrong in like the process. Like it's
No, I'm trying to figure out what I did
Okay.
when I did this. They got it wrong.
Oh.
So you don't want to take.
Oh no, I'm doing that. Yeah, my answer is I and 4. But I'm not gonna open this.
Let me see if I can do it.
Not really. Not supposed to. Yeah, it's just a really awkward problem.
That is so strange. What would I have done? This is how you're in, right? I just want to tell you that.
I feel like I don't know. I was just worried that I was looking into my calculator wrong because like I had everything else the same. That's just kind of why I asked.
I wonder if it's something as dumb as. Yeah, I don't know what I did there.
Okay.
How did I screw? What did I do to screw that up? So that's all fine. That's in the right spot. That seems about right. There's the Z, okay, and then that's the right stuff there. I don't know. But yeah, I think that that's.
And then this is just like another like stupid question.
Hold on 1 second while I'm thinking about this.
Okay.
Hey folks, if you look at question 6 in section 1103, part D, it appears that the answer on the review is incorrect. So I will, if at some point I'm going to update that if I get a chance today, but question 6D from section 3.
Okay, thank you.
Yeah. Okay, go ahead.
I just wanted to make sure I was finding the fourth roots right, but that's how you do it. So,
That's the way,
thank
I mean, you can do it
Yeah.
another way. There's,
I just wanted
if you did math, you can do like the nth root.
Oh, no
So
way.
you can just
Okay.
like type in a 4 there if you like doing
Okay.
that too.
All right, works.
But
Thank
that's
you.
going to be the same thing as doing this.
Okay. Okay. Thank you so much.
Of course. I want to pass these oldies back while I'm at it. That's what you need to be working on right now. I'm not going to argue with you about it.
Don't worry, I'll study. My tablet's steady. Down like mid number 13.
I think it's a whole time. Well, I wanted to do, that was curious as well. That was, I thought I did better than I did. So? I got an 8 now. I thought I did good. I mean, it was.
Well, yeah, this is cool.
Yes, sir.
I couldn't remember if you dropped the lowest test or doubled the highest.
Last year we doubled the high. Or last semester.
Should we change that?
I don't know. I don't make any decisions until I get to the very end.
I'm deciding to do one of my groups. You should drop every test except the highest.
Yeah.
Oh, that's interesting. That'd be an interesting way of going about it.
It's gonna be perfect on this one. Oh, yeah. Oh, this is an open.
Yeah.
I thought I wasn't gonna get anything.
No, the new ones I still have because they're still.
Yeah, I mean, like the tiny ones,
couple of people. Alright.
They put little mistakes on like a